All right, in these notes, we're going to be actually graphing parabolas. So in our 6.1 notes, we looked at what the shape of a parabola was. We looked at the pieces and characteristics of a parabola. Now we're going to actually practice graphing them. So again, just remember the parabola is a graph of a quadratic equation, which is this type of equation, y equals ax squared plus bx plus c, where your highest degree is x squared. So it's a x squared equation. The bx and the c, you may or may not have those, but for it to be a quadratic equation, you must have x squared. Now to graph it, we're going to be following these steps. First, we find the axis of symmetry, which is x equals negative b over 2a. And we get those values, b and a, from the equation that will be given in this form. And the AOS, or axis of symmetry, is the x value of the vertex. So once we find that, we can then make a t-chart, or a table of values, use the AOS, and then we choose two integers above and below for x. We have 5 values for x. We put those numbers into the equation to find y, to fill out the t-chart, and graph the parabola. Now, part of the reason we graph these is to find the solutions, which are the x-intercepts. And so if we haven't found the x-intercepts or the solutions after this first process, we must add more x values until we find them. So let's look at a first example here. So we have the equation y equals 3x squared minus 3. And if we think about that equation formula of ax squared plus bx plus c, we can see that in this equation we are missing that bx term, which means we can think of this equation as y equals 3x squared plus 0x minus 3. And that way we can determine what our a, b, and c values are. A is 3, b is 0, and c is negative 3. Now to find the AOS, or axis of symmetry, we want to use the formula negative b over 2a. And so we just plug in those values. B is 0, and a is 3. So we end up with negative 0 over 6, and 0 divided by anything is just 0. Okay, so we know that our AOS is 0. Now I like to set this up as the middle x value in my table. So I put it in the middle, and I like to draw a box around it because that shows that this is the vertex of our parabola. And so right away we know that we have an AOS of 0, which means we have a line running through the middle of our parabola right at x equals 0. And you don't have to put this dotted line on your graph, but it does maybe help you anticipate where your points should end up. Okay, but to find the points, we pick 2 numbers above and 2 numbers below the AOS. So that would be negative 1 and negative 2, and also positive 1 and positive 2. So just like any other t-chart, any other table of values, I'm going to fill this table out by plugging these x values into the equation and getting my values for y. There's not a lot of room to work here, so I'll do it over here to the side. Our equation is y equals 3x squared minus 3. And so just one at a time, I'm going to put these x values in for x to get my y value. So if I just set this up really quickly, I need 5 of these. Now, when you're doing this on your own, you might not necessarily show this work every time, but especially for the notes, I want it to be clear what's happening. So we have our equation, right? Y equals 3x squared minus 3. I'm going to plug in these 5 numbers. So first I'll do negative 2, then I'll do negative 1, 0, 1, and 2 for x, just like any t-chart you've ever filled out. Okay, so for the first one, for negative 2, I'm going to do negative 2 squared, which is positive 4, and positive 4 times 3 is 12. So that's 12 minus 3, and that equals 9. For negative 1, I'll do negative 1 squared, and that's negative 1 times negative 1, which is positive 1, times 3 is 3, and 3 minus 3 equals 0. If I plug in 0, which was my AOS, 0 squared is 0, 0 times 3 is 0, so 0 minus 3 is negative 3. And now something interesting is going to happen here. When we put in 1, 1 squared is 1, times 3 is 3, and 3 minus 3 is 0. So we went 9, 0, negative 3, and now we're back to 0. Same thing will happen with 2. 2 squared is 4, 4 times 3 is 12, and 12 minus 3 is 9. So if you set your table up correctly with 2 numbers below and 2 numbers above your AOS, when you get your y values, they will be symmetrical. And that's one immediate indicator as to whether or not you've done this correctly. You know, if you get symmetrical points, which remember the shape of a parabola is symmetrical, you know you've set up your work correctly. So let's graph them now. We have negative 2, 9, that's left 2, up 9. Right here. Negative 1, 0. 0, negative 3. 1, 0, and 2, 9. And so you can see we have this V shape, and do your best connecting it. It's not a straight line, so it doesn't have to be perfect. As long as your points are in the right spots, that'll be fine. So then just double check, make sure that you have this symmetrical picture. If you do some math incorrectly somewhere, you might end up with a graph that looks more like this, or some other incorrect shape. But you do want this symmetrical, soft V shape for your parabola. And if you're confident in your math, once you do your top half, the bottom should match it. It should mirror that. Maybe you want to do the math to double check and make sure your work is correct, but if you're confident you did it correctly, you can save a little time and just mirror that number. So there you have it. There's how to graph a parabola. Now we can fill out some information about it. Our axis of symmetry, which we found first, that's our AOS, that was x equals 0. And that is that dotted line that goes straight down the middle of the graph, which you don't need to draw, but it is nice to have a clear picture in mind before you graph of where your parabola will end up. The vertex is the point with the x value. That's the AOS right there at the bottom. That's the point 0, negative 3. This graph opens up, which we knew by the positive a value. The y-intercept, this is just where the graph crosses the y-axis. It happened to be negative 3 on the vertex point. It won't always be the vertex, but this one happened to be. Our solutions, remember, are the x-intercepts, and we did find those in our initial graph. And those are where it crosses the x-axis. Here and here are solutions. So that would be x equals negative 1 and positive 1. This vertex point is a minimum. It's the lowest point on the graph. And our graph is increasing for values greater than the AOS and decreasing for values less than the AOS. And that is determined by the shape of the graph. So as you move left to right, we are decreasing on the left side until we hit the vertex, at which point the graph begins to go back up. And so that is why we are increasing at values greater than 0, which is the AOS, and decreasing less than 0. All right, now all this information here is just good review, good practice on finding that information. The focus on these notes is graphing the shape, graphing the parabola. Let's do another one. Y equals negative 5x squared. Now again, we are missing those b and c values here, and that's okay. So we know that b is going to be 0 and c is going to be 0. So for our axis of symmetry, which is negative b over 2a, we get negative 0 over negative 10, which, because 0 is on top, that's just going to equal 0. So we know that our middle point for our table should be 0, because that's our AOS. And I like to set up the table, again, with the AOS in the middle. That way it is a nice symmetrical picture. So this is going to be our vertex point after we find our y values. And let's plug in 2 above and 2 below. So again, we have -1 and -2, +1 and +2. They won't always be these same numbers. It's just when we get an AOS of 0. So we have y equals -5x squared. Let's figure out what our numbers are for y. So first we'll put in -2. Okay, -2 squared is 4, and -5 times 4 is -20, which is quite a large number. But that's okay, let's keep going. Let's see what happens. Y equals, we're going to put in -1 squared. Well, -1 squared is just 1, so -5 times 1 is -5. Let's put in 0, this is our AOS. Well, 0 squared is just 0, so -5 times 0 is 0. Let's put in +1, which if our setup is done correctly, should give us the same thing we got for -1. 1 squared is 1, and -5 times 1 is -5. So that's good. And then lastly, we'll put in 2. 2 squared is 4, and -5 times 4 is -20. So we do have a nice symmetrical picture here. So our y values were for -2, we got -20. For -1, -5. 0 gave us 0. 1 gave us -5, and 2 gave us -20. Now we can just put these points on the graph. -2, -20 is way off the graph. We won't be able to graph that one, but that's okay. -1, -5 is here. 0, 0, right in the middle. 1, -5, and then 2, -20 is off the graph as well. So we know our shape looks like this. Goes down off the graph pretty quickly. And that's okay. We have a nice symmetrical shape. We did find the x-intercept. There's just one of them, but it does touch the x-axis there. So no need to add more points because we can see where it crosses the x-axis. And so we are done with that. Now let's fill out our information. The AOS, the axis of symmetry, right here down the middle, that was x equals 0. Vertex point, 0, 0. That's that middle point right here. This graph opens down, which again we knew because A was -5. The y-intercept is 0. Our solutions, we actually have one solution. And it's right here at 0, 0. So just one intercept this time. That's fine. Maximum or minimum, this vertex is a maximum because it opens down. It's the highest point on the graph. And that means that our graph is increasing for values less than the AOS and decreasing after the AOS. So for increasing, that would be x is less than 0 and decreasing greater than 0. All right. And again, this number here is the AOS. That's where the graph changes from increasing to decreasing, right there at the vertex. Okay, we have one more, went too far down. One more to look at. Y equals x squared minus 4x minus 5. And remember, this is ax squared plus bx plus c. And we do have all three this time. So let's find our AOS, negative b over 2a. So our b value here is -4. So if I have -4, that's actually +4. A would be 1, so 2 times 1 is 2. Our AOS for this problem is +2. And that's our middle point right here. So I want to set up my x values based on that AOS. So my goal here is to be symmetrical, I want to pick 2 above and 2 below. So that would be 1 and 0 below and 3 and 4 above. So my 2 AOS is the middle value, and the other 4 I pick based on that. So our equation is y equals x squared minus 4x minus 5. It's going to be a little more work here, but that's okay. So first we put in 0. 0 squared minus 4 times 0 minus 5. Well, 0 squared is 0. 4 times 0 is 0 minus 5. So we have 0 minus 5, which is negative 5. Let's put in 1. 1 squared minus 4 times 1 minus 5. 1 squared is 1. 4 times 1 is 4. So 1 minus 4 is negative 5. Minus 5 is negative 10. Let's put in 2. I just realized I made a mistake on this last one. 1 minus 4 is negative 3. Negative 3 minus 5 is negative 8. That's my fault. Let's keep going. Put in 2. We have 2 squared minus 4 times 2 minus 5. So 2 squared is 4. 4 times 2 is 8. Okay, so 4 minus 5 is negative 4. Minus 5 is negative 9. And so we should get negative 8 and negative 5 for the next two. But let's double check. 3 squared minus 4 times 3 minus 5. 3 squared is 9. Minus 12 minus 5. We do get negative 8 there. Then we're going to put in 4. So that's 16 minus 16 minus 5. We get 0 minus 5, which is negative 5. Okay, that looks nice. We have a nice symmetrical list. Let's see what it looks like when we graph it. So 0, negative 5 is here. 1, negative 8. 2, negative 9. And that's our vertex. So we should be going back up after this. 3, negative 8. And 4, negative 5. Now the problem here is that we did not hit our intercepts. Right? We haven't touched the x-axis yet. And I don't really want to guess, because it isn't linear, it's a curve, so I can't see exactly where it will cross. So we should add more numbers. Let's add negative 1 on this side and 5 on this side. So let's do negative 1 first. Negative 1 squared minus 4 times negative 1 minus 5. Well, negative 1 squared is 1. Negative 4 times negative 1 is positive 4. And then minus 5. So 1 plus 4 is 5. 5 minus 5 is 0. That should actually get me there. Let's double check and make sure that we get 0 for 5 as well. So 5 squared minus 4 times 5 minus 5. So 5 squared is 25 minus 20 minus 5. That does also equal 0. So we have a point at 5, 0. And there you have it. And that's a nice symmetrical picture. So we did have to add a couple extra points on that one, but we just use our list, right? We just go to the next number up and the next number down. So what's nice about setting up your table based on your AOS in the middle is that you know what the next integer is if you have to add numbers. So I like to start with the AOS, find the vertex in the middle, and then just branch out from there. Okay, now we have our picture. Let's go ahead and fill out our information. Axis of symmetry is x equals 2. That's our x value from the vertex, which is the point 2, negative 9, right in the middle of our graph. This graph opens up. The y-intercept is negative 5. It's where it crosses the y-axis right here. The solutions are the x-intercepts, which we found after our original 5, these two numbers right here. So that would be x equals negative 1 and 5. Our vertex is a minimum because the graph opens up. And from left to right, we are decreasing and then increasing. So we're increasing after the AOS. X is greater than 2, and we're decreasing before the AOS. So, simple process to explain. Sometimes, as this one showed, this can take a while to get all your numbers. Depends on the equation that you get. Some of them are much more involved than others, but in basic terms, you first find your AOS, your axis of symmetry, with negative b over 2a. Use that point to determine your other x values that you put into the equation. So 2 above and 2 below the AOS. Plug all those numbers in for x, get your values for y, fill out your table, graph the parabola. Then if you didn't hit your x-intercepts like we didn't here, add a couple more points until you reach the x-axis, and then you can fill out your information.